And hello everyone, welcome to our OpenFoam video. And well, in the last video we're talking about snappyHexMesh. And as long as we kind of define using our STL surfaces what regions there are, and then we tell snappyHexMesh, hey, I want to, okay, let me scroll to the point. Where's the point? Yeah, there you go. Yeah, we tell the cell zones according to locations in mesh. That means to say, all right, if I bounded a point like this, we specify the x, y, and z coordinates. That will be the proper cell zone. Okay, so for example, I have region 1. I need to designate. Okay, this STL file actually encloses a surface there, and you need to provide XYZ coordinate to say, okay, this is region 1. And if you have the part outside region 1, we can call it region 2. You also need to provide an X, Y, and Z coordinate. This is what the things are for here. So for the region heater, we use 0.005 X, Y, and Z to call it the heater place. Then we call the right solid 0.05 and 0.005 for Y and Z. Similar for all the other regions. And that's how we define our region, our cell zone. Now the thing, of course, you gotta be careful, as spoken in the last, in the snappyHexMesh video series. Actually, I've talked about it before. You cannot put these points on a face. These points cannot be on the face. What do I mean to say is that when we have our grid and when we have our cells, and each cell has 6 faces, I mean if it's orthogonal, then we cannot have our coordinate exactly on the face. They must be within the cell. We have talked about that before. Alright, so question is, how does this mesh actually look like? So if you're wondering why I was downloading FreeCAD, why was I downloading and installing FreeCAD? It was for the purpose of visualizing this STL file in a little bit more detail. So FreeCAD is like a computer-aided design. And you know, last time I was using Windows Builder in the OpenFoam Intermediate video series to do to kind of do the tri-surface files. But now I want to use something a little more robust so that we can talk about using doing something more concrete rather than just simple cylinders and spheres. But for now, I want to use this to open up the, let's see, desktop. Yeah, I want to open up the so if you want to open the cylinder file that we use for our snappyHexMesh, this is what the cylinder file will look like. Okay, so if we zoom in, we can let's see. Yeah, then we can use this to shift around in 90 degrees angle, right? So this is how we rotate in the FreeCAD. So you can do that. It's not exactly like ParaView. Okay, so this is the pipe geometry. You can zoom in and zoom out. Alright, and you can use your arrow keys to shift around this FreeCAD, and you can see the shape. Now if you want to drag it around, you press your middle mouse button and the scroll wheel button, and you drag it around. And you can look more on this. Okay. So select is to press your left mouse, pen is to hold the middle mouse, and zoom is to use this middle mouse wheel. Okay, so I'm going to use the mouse wheel to scroll in and out. Rotate view first method is to hold this center and left mouse button together. Okay, so let's try that. Okay, not sure why that's not working. Okay, anyway, oops. Okay, so pen mode is to hold Control key and press the right mouse button once, then move the pointer. So this is also pen, which is easier than the pen mode over here. Zoom mode, Control Shift and right mouse and move the pointer. So this is the zoom mode. Okay, very nice. So Control and right click, Control Shift and move in and out. It's much easier. Rotate mode is to press Shift and you press the key, then move the pointer. So Shift, and you see we can rotate. So the rotation will be around that axis. So a pen is to Control and Shift, Control and drag with the right click, and Control, okay, Control and Shift will zoom in and out. Okay, Control and right click will shift it around. Control Shift is zoom, Shift is pen, Shift and drag. So that's panning. It's a little bit to get used to for FreeCAD, especially if you're used to ParaView. But it is what it is, and it's easy to at least take some getting used to. Get used to it, but that is what it is. It's a simple model of a cylinder. So I'm going to delete this, and we'll want to look at something more complex, which is our model. So I want to go to the shortcut, and I want to go to the GitHub repository. Wrong one. OpenFoam Heat Transfer YouTube, multi-region foam, snappyMultiRegionHeater. Now the stuff should be in constant, and it should be in tri-surface. So let's take a look at the geometry. Okay, using what we've learned, we should be able to use Shift and right click to drag it around. Shift and right click, Control to pan, Control Shift to zoom. Okay, so this is FreeCAD navigation. Just remember these three things. Control right click to pan, and you can Control Shift to zoom using the right click button, and Shift and right click to rotate the thing. So you see this snappyHexMesh is pretty rudimentary. Okay, the geometry at least. Now okay, let me pan to bring it to the center. Yeah, so you can see there are a few regions here. There's a heater region. You can see at the bottom there's a heater region, which is probably this T-shaped thing. There's a left solid and the right solid. Depend on which perspective you are having. If not, you can just use this to reset. This is the set to viewpoint 1, where we are looking at the front. This is the side. Okay, these ones are the standard viewpoints, but of course you can rotate as wish. So again, the heater is this T-shaped thing, and then there's a left part and the right part. So you can see it's not completely enclosed, but it clearly separates out the block mesh into several regions. So if you want to define a region, you have to ensure the region itself is enclosed, and there's nothing. I mean, it's not like we have some random piece of item lodged in here, like a sphere that we want to lodge in here. I think that there should be some different way of defining that. Okay, but that's how this case is structured. So we can use snappyHexMesh to do this kind of thing. Alright, we can use snappyHexMesh to do this kind of thing where we define regions. So that's not a problem. The only thing is that for more complicated geometries, we will have some other considerations. For example, alright, what I eventually hope to do is to have a pipe of some sort. Okay, and then I want to lodge an object in here. So I want to lodge some kind of object in there. So for starters, maybe a sphere. Okay, I want to have a pipe flow, and then I want to have a sphere in there, or maybe a collection of spheres, or some pack bed kind of thing. And I want the fluid to flow through, and then see the effect of heat transfer on these spheres. So yeah, doing a snappyHexMesh for that one and doing an STL for that one may prove to be, there'll be some learning curve to it, but yeah, that's for next time. Okay, but we see the logic here. The logic is that we use snappyHexMesh to define cell zones. Okay, so I'm going to zoom straight to the top. Okay, so we can run snappyHexMesh and we'll put override. HexMesh override snappyHexMesh.log and put a background. Okay, should take less than a few minutes to finish. Okay, so if you want to have a FreeCAD, you can download from this FreeCAD webpage. It's way more. You can do much more with it than say the 3D builder. And these are the basic commands for FreeCAD, like how you want to zoom and pan. This is very important. So I'm going to put these inside the tutorial. Description. Sorry. So put this in the description. All right. So you know how to use FreeCAD. A little bit of introduction. Now this snappyHexMesh is finished, and what we want to take a look at is So let's see. All run serial. All right. So this is the correct sequence of steps. Next thing we want to do is let's take a look at the snappyHexMesh dictionary. Okay, and the mesh quality dictionary. So we have the castellated mesh, which is true. Means to say it starts to cut out some. It uses the geometry to cut out some layers of the mesh, and then you can segregate. So we have a snap, which is also true. So the snap is snap is basically you want to smoothen that surface to fit your geometry so that it does not look blocky. Alright, so we take in a geometry called geometry.stl, and we have already seen what it's like in the FreeCAD. Yep, so this is FreeCAD. Yep, so you shift and right click to pan around to rotate the thing. Alright, so let's see. Next thing, castellated mesh control. Castellated mesh controls is here. So we have talked about it before. I'm not going to go through it again. Alright, so this is explicit surface feature, explicit feature edge refinement. So So what this file is going to do, what snappyHexMesh is going to do, is going to look for this file called geometry extended surface geometry extended feature HMesh. And it's going to refine it to level 1. So remember, we are talking about surface feature surface feature extract, and it's going to go to constant, and it's going to go to extended feature HMesh. And it's going to look for this file, right? It's going to look for this file. Let's see. So that's where we're going to look for that file. And see, we go to the tri-surface. We see a geom.emesh over there. Okay. And we see the same points over here. Okay, not too bad. So we want to let's take a look at the system snappyHexMesh dictionary again. So it's gonna look for this file called geometry extended feature HMesh. Right. So this one is being ignored, and okay, it will go to this you look for this file in this folder. Apparently, you don't have to be in the constant try surface anymore. It used to be there, but I don't think it is anymore. It's going to look for extended feature mesh, and then you're going to find the file right here. Well, how do we name this file? We have to take a look at the surface feature extract dictionary, and it's going to say extract from surface blah blah blah. Yeah, this is how it's going to be extracted. VI surface. Okay, snappyMultiRegionHeater VI surface feature extract.log. So it's writing this feature chtMesh to try surface geom.emesh. Alright, I guess this is how it works. It seems to be a bit of a conflict. First, it looks as if the emesh is not. Yeah, first it looks like this file is being read, but I don't see a geom.extendedFeatureHmesh inside constant try surface. I only see this file. Maybe the extensions are the same or something, or it's maybe reading from somewhere else. It may be reading from the other file I was telling you about just now. Or by default we can just use geom.emesh inside constant try surface. Maybe that's a simpler way, but apparently it's commented out in this file. Not really that sure why. Anyway, but that's the idea. The intent of this features entry is to say, okay, I want to look for some extracted features using the surface feature extract utility, and yeah, you're going to do some refinement along the edge. Now then, we have the surface-based refinement. We talked about this before, the geometry surface, and it does that. Okay. So next thing is to resolve sharp angles. Okay, resolve feature angle is 30. You can skip this. Refinement regions, we don't have any more regions where we specifically have extra refinement. Now this one's important, it's called mesh selection. Like I was saying before, you need to say XYZ. Alright, I want to say this is the heater, this is the right solid, this is the left solid, blah 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 blah. Okay, so this is how we define regions and cell zones. So once the cell zones are defined, then yeah, it's okay. So these are the snap controls, how the snapping is being done, so that you can have a smooth surface. And add layer controls, which we kind of don't mess around this time around. Alright, this one is a mesh quality control, generic mesh quality settings. Any undoable phase, these determine where to undo. Okay, not sure what to do that, but again we have this mesh quality dictionary, and let's take a look at what mesh quality dictionary is. Okay, so it basically is this # include etc. in k6 mesh quality dictionary. So what it's saying is that it includes the default parameters from the OpenFoam case dictionary. So OpenFoam comes with the case dictionary, and this is the default mesh quality dictionary. So nothing much to change there. It's just taking OpenFoam's default settings for mesh quality dictionary, and we are making no modifications at all. It's just there to be, read. Okay, so this one we don't touch. Okay, so now next thing to do is to restore the initial fields. Okay, so I'm going to cpar 0.original into 0. So that basically does the restore 0 directory command. Next thing to do is split mesh regions. Now we already know what split mesh region does, but just for the sake of looking, let's take a look at polymesh and take a look at the cell zones. VI cell zones. Okay, so we have 5 cell zones. One is called heater, 640 cells, and these are labeled as follows. And then the next cell zone is called right solid, and then you're gonna keep scrolling, and you're gonna see the left solid here. It's another cell zone. Yep. So yeah, these are the cell zones. These are how the files are written, and we have labels based on that. So snappyHexMesh has made cell zones, right? Cell zones for, you know, the whole thing. So no problem. So we do split mesh regions based on the cell zones. Okay. So I'm just going to do split. Okay. Navigate up. Okay. Yep. So based on the cell zones again, we're going to run split mesh regions, and we're going to do that override. So split mesh regions, cell zones, override. Okay, let's do a before first. We take cd0. Okay, we see all this being constructed here already. Okay, sorry, cd0. Yeah, we see all this over here. There's nothing, no regions in the 0 directory. We will need to we will need to do a split mesh regions. So I'm going to run split mesh regions, override, or cell zones, based on the cell zones that were done by snappyHexMesh, and we do override. And I'm going to do in split mesh regions.log. So split mesh regions, we already know what it does. So cd0, you see we have 5 regions there now. Okay, so we already gone through this before. We can take a look at the system split mesh. There should be a, there's no split mesh regions dictionary, but we can take a look at the log. Okay. So it's 5 regions, writing region per cell file for manual decomposition into this cell to region file. Just gonna add all the patches that are necessary. As usual, we have all these regions from 0 to 4, so that's 5 regions actually, 0, 1, 2, 3, and 4, and 5. And that's how the regions are being constructed in the 0 directory. So that's fine. And then this is where we remove all the redundant files, such as new t, alpha t, blah blah blah. And we see for the 0 file here, let's say the heater here only has the relevant information there, nothing else. There's no fluid based properties in that directory. So whether it's for the 0 here or in the processor, it's basically the same thing. Then it's going to run change dictionary as before. So that helps to write in the boundary conditions, so that we will have to see system heater change dictionary, and these are the temperature profiles. So internal field is 300 at first, and basically this is alright. All these boundaries are called 0 gradient. Everything is 0 gradient at value 300 first. Then whatever is a processor, if it's a parallel kind of a decomposition case, that's going to be written as processor. So this actually accommodates for the parallel running of this case. If you are running in series, you don't have to write this down. And this is the heater to wherever. This is compressible turbulent temperature baffle mix. So yeah, it's based on the heat transfer model, and min y is based on fixed value uniform of 500. So the lowest y phase is 500 Kelvin, and that's a constant temperature boundary condition. That's how this is being written. So that's just a quick run through of the preparatory steps just to get chtMultiRegionFoam running. So the steps are basically the same as chtMultiRegion Simple Foam. The only difference I think is in the FV solutions and FV schemes. Of course, one is Simple Foam, one is Pimple Foam, so there will be some differences there as we have discussed with before. And yeah, let's see whether this file is finished. cht. Alright, let's go all the way to the bottom. Oh, it's finished in about 300 seconds. That's perfect. So we can see the temperature evolution in ParaView. So I'm just going to do a touch. Touch snappyHeater.foam. So it's in OPT OpenFoam blah 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 blah. So let's take a look at that, where we can find this. Okay, gotta go up, 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 up. Up. Up one more. It's in OPT. What's the directory? OPT OpenFoam V1906 V1906 and tutorials, heat transfer, chtMultiRegionFoam, and we take a look at the snappyMultiRegionHeater. That's where you can see our results. Now let's take a look at the wireframe, and we look at the temperature profile. So again, you see the bottom is very much hot, the rest of the thing is cold. Okay, that's why it's so red colored. So you can see that the thing is actually heating up. Okay, for some reason there's a heat up and a cool down over there as heat is being diffused through the system. So there seems to be this kind of oscillating effect for some reason. Okay, but that is the case. You can see this again, the T shape here, the heater kind of a thing, and then we have the left and right baffles, and yeah, quite curious why it's behaving like that. So okay, let's see the thermophysical properties of each region. Top air, bottom air. Thermophysical properties. It's air, alright. Yep, it's just air. Okay, perhaps there's some convection phenomena going on, which I'm not really aware of, but yeah. Perhaps when heat is conducted up and then it is being spread throughout. That's why it happens like that, like so. It's not a steady state, but it's a yeah, transient case. Let's see the control dictionary. See, I'm suspecting it's something to do with the time step, but oh, it's not. Maybe that the time step was the error, but that wasn't the case. Anyway, this is how the case looks like. Perhaps we can talk about constructing our own case soon, since we have learned how conjugate heat transfer cases are structured. You can do a basic conjugate heat transfer case with some time varying bounding conditions or something like that, based on what we have learned. Okay, so that's pretty much it for the tutorial case discussions. Thank you. I'll see you in the next video. Bye bye.